Statistics. Do you remember statistics from last year? We're focusing on this thing called expected value. So you have a bag of marbles. What's the expected value? What's the expected outcome? You know, what is the expected likelihood of me picking a red marble or a black marble or a blue marble? What's the expected value of me flipping a coin, etc.? What's the expected value of me making profit on this business that I own? All these things apply to probability expected value. So you usually use an expected value table to find these things, or you can use your calculator. Okay? So your goal is to identify discrete random variables and their probability functions, calculating an expected value. Okay? So what is the expected likelihood of something happening? Okay? This is given by the notation E bracket capital X bracket. Okay? Expected value. Have you heard of this before? If you haven't heard of this, write it down. Capital E bracket capital X bracket. Expected value. What is the expected outcome of an event? Okay? So let's look back at the goal again. Identifying discrete random variable. What does discrete mean? It's countable. Okay? Do you remember discrete versus continuous? So number of goals, is it countable? So it is discrete. Shoe size, that should say, not show size. Shoe size, is it countable? Yes, so it is discrete. Time taken to run 10 kilometers. Is it countable? It's measurable. Okay, so you have decimals, you measure it with a stopwatch. It is called continuous. I want the expected outcome. I can use a formula which I'm going to show you to find that, which is here. Do you understand expected outcome? What I expect to happen. What does this mean? This is a Greek symbol called mu. Does anyone know what it means?
Micro. That's a micro.
In the class today, does anyone know what it means? It means the mean. The expected value is the mean. That's what you expect to happen.
So mu
to find that, we do this. The sum of every x value it could be, remember that's what the little x is, every x value it could be times by the probability of that x value. So let's say this is the expected number of red cars I'm going to see. I could see 2 red cars, I could see 3 red cars, 5, 8. When we do this big formula for EX, that tells me, let's say it's 3.2, that's the expected number of red cars I'm going to see. If we add all of the probabilities together, they have to add to Y. Why do they have to add to 1? Because you can't have more than 100% probability. Yeah? The probability is between 0 and 1. Yeah? So the total likelihood is 1. So if we add all of these together, it needs to add to 1. So what's A equal to? 0.3. So the likelihood of 5 red cars is 30%, or 0.3. Yep. So that's how you find the unknown A. There'll be some questions about that. Now it wants us to find the expected value of the random variable, and I've just chosen red cars. Yep. Look at the formula. Does anyone remember what the formula was? The sum of
x times p of
x, and I used little p x. That's on the formula sheet. In other words, the capital X is equal to the little x. So I'm summing all of these times their probability. Okay? 2, and what's its probability? Plus times. So we're multiplying all of the little x's by their corresponding probability. So if you put that into your calculator, or you can actually do it in your head, it's not that difficult, you'll get 4.4. So the expected outcome of my red cars is 4.4 red cars. At expected value 2 times the outcome we want. Okay? So to do this, you sum 2 times x times the probability of x equals that. So you do 2 times every x. 2 times 2 times 0.2 plus 2 times 3 times 0.3. If there's a constant at the end, what do you think I do? No, you just minus 2 at the very end of the equation. If it's squared, you just square every x. Okay?